Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is asteroid collision. So, before we start, let me just quickly share my screen or the question itself. So, I should be audible. Yes. Hi, Rohit, how are you? Yeah. So quickly just recapitulate this question for just next 1 minute or 30 seconds, and then we would start the explanation. This problem is somewhat very easy if you have already done some problems over this. Hi Nekaj, hi Rishit, how are you? Okay, we are good to go. Yes, I am fine too. So Nakaj and Rishit, you would come to see POD on tomorrow and day after tomorrow also, or what? Chalo, let me just see. I think tomorrow or day after tomorrow won't be. Don't know. Just let me change this to some other color. Just the background. Let me see some good background or the black one. Yes, this one is good enough. Yes. Chalo, let's move forward. Okay. This question is very easy to understand. I would just explain you the question, won't read the problem statement again. Mhm. Okay. So this question is a little bit easy to understand. This is telling us that there would be two asteroids. Okay. Basically, you can just visualize it as a shooting star, not asteroids, but a shooting star. Now, if it is positive, then it would be going on the right hand side. If it is negative, the star would be going on the left hand side. Okay. Now there are some conditions. So if there are some asteroids, they would be colliding with each other. On collision, a resultant value would appear. And what would be that resultant value? It is very easy to visualize. Okay. So if this positive asteroid, if this is the positive side, this is the negative side. Okay. So if this positive asteroid is bigger than the negative asteroid, then this would sustain, okay, and this one would sustain, and this would get submerged into the big one. If this is the small one, let me just draw it with the same color. If this is the small one and this is the big one, then this would sustain. Basically, they want to say that the bigger one would sustain, okay, and if they both are of the same dimension, then both of them won't sustain. This is what it is all about. Okay. Like they both would just collide with each other, they both would be distorted, and it would be done. So basically, kya hai? There are some values which explain the dimension. Okay. Fair enough. Now, suppose this is the asteroid that is small, and this is the asteroid that is big. Okay, this asteroid is coming in this direction. How is the direction determined? The direction is determined by the positive or the negative side. Positive means on the right hand side, negative means on the left hand side. So remember, okay, right, doing it the right way, going in positive direction. Just try to visualize with that. Right way, positive, okay, and the other one is left way and negative. Just remember it, okay, and then the problem is very easy to understand. Now let us have some test cases and it would be good to go. Just let us see the first test case. So now see what would happen basically. Yeah, see, this 3 is going in this direction. This 5 is also going in this direction. And this negative 3 is coming in this direction. Okay, basically they both are on the same x-axis. You can just visualize this. They both are on the same x-axis. So if they collide, if 5 and 3 collide, okay, then the big one is what? 5 or 3? 5 is the big one. So 3 would be submerged into 5 and this would sustain. Now, as they both are moving in the same direction, like I and my friend, okay, they both are moving in the same direction, they won't ever collide. Like, suppose I did a mistake, okay, suppose basically I did a mistake, and this is suppose my girlfriend, this is me. So I'm running at around 6 kilometer per hour on a straight road, and she is also running in 6 kilometer per hour on a straight road, and I am basically in front of her. So if we both are running with the same speed, then she won't be able to catch me at any time. Fair enough. So in the same manner, if 3 and 5 are moving in the same direction, then they both would never collide. Why? Because 3 and 5 are not speed. The speed is absolutely same for everyone. 3 and 5 are just dimension. The example is to differentiate that 3 and 5 are not speed, they are just the dimension. For everyone, the speed is same. Okay? Chalo. So it can be visualized like this. Suppose this is 3. This is, suppose this can be like this. Okay. Like suppose this is the small one, this is the big one, and this is the same small one because 3 and minus 3. So this is going in this direction. This is also going in this direction. This is going in this direction. This is, so this is representing 3. This is representing 5. This is representing minus 3. So now see that if these and these two collide, then the smaller one would get submerged. Okay. And they both would move in the same direction, no speed difference. So they both would sustain. So now I had a lot of query regarding this, that even if this be like 3 and 5, why they are not colliding. This is the reason, that they basically don't define the speed. Neither in this question dimension defines the speed of the asteroid. So they won't ever collide. Am I clear with the problem statement or not? Then we would move forward. That is why 3 and 5 would sustain. That is why the answer to this is 3 and 5. Now quickly let me know if this thing is clear or not. Namaste, Yash sir. Quickly give me yes or no in the chat, and then we would just move forward. Okay, I'm done. Shall let's move forward. If speed is different, then the question is only different. Okay, in this question, we don't need to consider speed. But I would just tell you, if the speed is different, basically what we need to do is we need to solve this question in a different way. Here only, I would just explain at the end. Just remember this and ask me towards this end. Okay, I would explain you. Chalo. Okay, this is done. So now this question is, to be honest, a very simple one. Why I would say you this? Okay, suppose there are two kinds of asteroids. Okay, first asteroid is that is moving on the right hand side. The next one is that is moving on the left hand side. Only two kind of asteroids. Okay, so now what we need to do is, suppose we have we have some asteroids. Okay, like suppose L and R, suppose some. So we have right moving asteroid. So we can just keep it as it is. Okay, because right moving asteroids. Okay, so now again we have a new right moving asteroid. So what we would do? Right moving asteroid and right moving asteroid won't cancel each other. No? बिकॉज अगर मैं दौड़ रहा हूँ राइट के साइड 5 किलोमीटर पर आवर में, और मेरा दोस्त भी दौड़ रहा है मेरे पीछे 5 किलोमीटर पर आवर में, मेरी गर्लफ्रेंड भी दौड़ रही है उसके पीछे 5 किलोमीटर पर आवर में, बेसिकली लेफ्ट ट्रायंगल। ओके, सपोज ऐसा हो रहा है। ओके, so we three won't cancel each other. What I'm trying to say is, suppose I am running in a straight road with 5 kilometer per hour. My friend is running behind me in the same pace of 5 kilometer per hour. And behind my friend, my girlfriend is also running behind my friend at 5 kilometer per hour. So we won't cancel each other out, no? So in the same manner, if we have a right moving asteroid and we have a new right moving asteroid, we won't cancel each other. Rather, the the person who has just right moving asteroid would just sit in front of me. Same manner. Now suppose I have a left moving asteroid. Let's say, suppose I was running and I saw my father coming in the opposite direction. What would happen? Either of us would cancel each other. So in the same manner, if a new right moving asteroid is coming in, it would add to the picture. If a new left moving asteroid is coming here, then either of them would cancel each other. What would cancel? The lower one would cancel. So, minimum of left or right would be cancelled out. Whatever would remain, let's say, suppose L is remaining. Okay, let's say, suppose L is remaining. Now, again, okay, suppose my friend is also afraid of my father. My father came in opposite direction. I ran away. Now my friend also knows my father. Okay, he is also afraid of my father. Okay, he also saw my father and he ran away. In the same manner, see, right is also there. Again, left has sustained itself. Okay. Now suppose right is also small than left. So again, right is again getting submerged and only left would sustain at the end. So it is just like this. The algorithm would be very simple, to be honest. Okay. The algorithm is simple. The algorithm is that suppose if we have nothing, then left moving or right moving, there won't be any difference. Like suppose if there is no one running in the road, even if my father come, what will he do? He would just walk and go away. If suppose I am running all by myself, I would just walk and go away. I won't cancel anyone. I won't be afraid of anyone. So in the same manner, if initial state is empty, okay, if the initial state is empty, so I would just write here. If the initial state is empty, okay, initial state is empty, then just insert either of it. We don't have any option. Just see how we are visualizing the things. Visualizing this question is just the algorithm of this question, to be honest. Okay. So now the next thing is that if suppose, let's say there are two scenarios. Okay, let's say there are two scenarios. This is the first scenario, this is the second scenario. Suppose the first one is the left. So we would keep it. Suppose the first one is the right. Okay. You only draw out the test cases by yourself. Then you would be able to solve it. Okay, क्या क्या हो सकता है? अगर खाली हो तो लेफ्ट और राइट आ सकता है. लेफ्ट और राइट में जो आएगा वो टिक जाएगा. If the state is empty, then left or right, whatever would be there, it would sustain. Now suppose we have two conditions. The first element is left, first element is right. Okay. Now, if this is moving on the left side, after left, we have a new element as left only. We have a next element as right only. Okay. If we have a left moving element, so that is suppose my father is also running in this direction, my mother is also running behind my father in this direction, so they won't cancel each other out because the speed is same. So left and left would be again left and left only. Now suppose left and right. So see, left is running in this direction, right is running in this direction. Suppose suppose I am running in that direction and father is running in that direction. In this side also, we won't cancel each other out. Okay, we won't cancel each other out. There is no option because they both are moving in different directions, so they won't ever collide. So left and right would remain. Am I clear with the first scenario or not? Tell me this. Only the last scenario is left, then the implementation is left, and then this would be done. Am I clear with till this point or not? Give me a quick one in the chat. Give me a quick one. Okay. Clear? Chalo. This is good enough. Chalo. So now the right thing. Okay. So after right, we can have a left. We can again have a right. Okay. So right and left. So right is moving in this direction and left is moving in that direction. Okay. So now this would be a collision. So now what would happen? The minimum of the maximum would remain because there is a collision between left and right. So maximum would remain. So that the value would be maximum of left and right. Okay. Now suppose we again have right and right. Okay. So both are moving on that direction. I am running and my girlfriend is running from behind in the same speed. So they both would remain. Okay. So if the state is empty, be it left or right, insert it. If the state is not empty, then this would be the happening. Now this is the algorithm, the simple one. But the problem is how would we implement it? Okay. Why we need to implement it? There are some few things that needs to be understood. Okay, the implementation is a problem here. This is an implementation problem, not an implementation problem. This is a problem which would test your skill of data structure. Okay, so now let us see. So see, what would happen is, suppose there are some right there. Okay, and now comes a left. Okay, let's suppose we have 5, 6, 7. Okay, everyone moving on the right hand direction, positive right hand direction. Okay, now we have a -9. Okay, we have a -9 which is moving on left direction. So what would happen is this 9 would cancel out this 7, would cancel out this 6, would cancel out this 5. So basically what needs to be done is we need access to the last element to see if it is small or big. So the very first need is access to last. Okay, and removal also. Access to last and removal of last. Basically, this would become the next point. So we need the access of the last element as well as the removal of the last element. Okay. Now, what are the other things? Now, suppose this element is 7, 5, 3. So this element is, suppose, let's say -6. So what would happen? This would remove 5 and 3, and after that, it can't remove. So suppose this is also -6. This is -6. Okay. So both are negative. We need to keep it at this position because they both are moving on the left hand side. So they won't cancel each other out. So now we need an insertion at the end. So we need a insertion at the end. So we need insertion at the end. We need access to the last element. We need the removal of the last element. What is the data structure that fulfills this criteria? Tell me. What is the data structure? Tell me the name of the data structure which fulfills this criteria. Give me a quick yes or no. I would just quickly check from this. Let me just see. GFG practice. Asteroid for the sound and all. This is stack use case. Absolutely. This is stack. Okay. Great Rohit Nekaj and all. Edge cases are there. No edge cases, man. No edge cases are there, to be honest. Okay. Like what can be the edge cases? Either there would be element, either there won't be any element. If there are no elements, be it left or right, it would be kept. If there are some elements, we would compare. Okay. And it's simple. There is no edge cases. Chalo. Now let us quickly implement this. Okay. So I think it is good to go, and I would just present the tab that would make this asteroid collision. Yup. Okay. Fair enough. This is fine, na? Okay. Chalo. This is fine. So I'm a very lazy person, would have this as A and would have this as lowercase m so that I don't need to press shift or caps lock again and again. So I would have a stack of integer because we are having integer. Okay, stack st, simple enough. Now I would be iterating over the for loop. So for int I is equals to 0, I is less than n, and I plus plus to iterate over all the elements. Now I would say that if the stack is empty, okay, if the stack is empty, okay, if the stack is empty, or okay, if the stack is empty, we would simply push the element. Okay, st dot push a of I. If the stack is empty, we would push the very first element. Okay, shallow. We would push that element. Now comes the point where the stack is non-empty. It has some element. Okay. Oh, okay. We can just have a condition here itself. Okay. If the stack is empty, or we have some right elements. Okay. Like suppose we have AI is greater than 0. Like suppose we have some right moving elements. So right moving elements won't cross in any case. Okay, so we would keep that. Okay, so either what can be the scenario? Either there can be initially kept right or initially kept left. This is what is there. So let us see. If there is initially kept left and right, okay, there is initially kept left and right comes to the picture, then LR would be there. That is, no cancellation would be there. If right is also kept and new right is there, then RR is there. That is in the same scenario. Okay, either of the case, if it is a right, it would just add up. Okay, so I have just kept it here. This is the reason why. Now, we see an element which is a negative because here it would cater the positive element. At this point, we would cater the negative element. So while the stack is non-empty, this is the very first thing that you should do in case of stack. Okay, why? Because whenever you want to access the top element of the stack, please confirm that the stack has some element. So if the stack is not non-empty, that is, it has some element, then access the top. Okay, and the top is greater than 0, and the top is a right moving particle. Okay, and then okay, the top element should be smaller than this negative element. This negative element should prevail. Okay, so st dot top is less than the current element. Okay, abs of a of I, because it is a negative element, no? So we need the absolute value of it. Okay, then if suppose the last element is a right hand side element. Okay, right hand side element, and this, suppose this is the right hand side element and this is the big negative element. Okay, if this is the scenario, then this would disappear. So last, to remove the last element, s dot pop is there. Okay, after all this is done. Okay, after all this is done, so we now have, if the stack is non-empty, again, if the stack is non-empty, st dot empty. If the stack is non-empty, that means it has some element. And st dot top. Okay, we would cater all the values. Like first it is less, then it is equal, then it is more. Less, equal, more. So if the top element is equal to the ABS of the current element. Okay, if the top element is equal to the ABS of the current element. If the top element is ABS of the current element, then also we would simply pop. Okay, pop that element. Okay, because suppose they both are of the same size, so both would burst. Simple enough. Now the question is, if the stack, if the stack is t dot empty, again same, non-empty, non-empty, just check it. Okay, if the stack is empty, okay, or st dot top is less than 0, that is, suppose if the value is negative. Okay, negative means what? Left. So if the value is left, whatever be the scenario, we have a new element coming in. Okay, we have a new element coming in. So st dot push a of I. Okay, so now this for loop is complete itself. Okay, let us just see again. So if the element is a positive element, we would simply push it. Okay, new element is a positive element. So see, if the new element is a right element, it is getting added. If the new element is a right element, it is again getting added. Sir, this is a stack use case. Okay, we would talk about this. Okay, now we would just take out all the elements, store it in a vector, and then return it. Okay, but instead of that, what we can do is we can directly use a vector head. Okay, so st.empty would be just this. Instead of st.empty, we can have if st.size is equal to 0. Okay, if st.size is equal to 0. Very first thing, st.size is not equal to empty. Okay, so you can just use like this. Okay, I won't have this again. Rather, I would just, so what I would do is I would have a vector. So you can directly use a vector because accessing the last element of the vector is also constant. Taking out the last element of the vector, that is pop back, is also constant. Everything is constant. So and you can just use a reverse function. And indexing is also there. So answer. Now what I would do is while is equal to no st dot empty. Okay, while the stack is not empty, then we would say answer dot push back st dot, and then we would just remove it. At the end, we would just reverse this, reverse answer dot begin, comma answer dot end. चलो हो गया. चलो, let us see how many mistakes are we making. Okay, why if sts is not equal to, okay, I just mistyped it after I removed it. Okay, s was not declared while the stack is not empty. Okay, I have missed a lot of s. Any other, let us see. Oh, okay. Chalo, let us try to submit. Okay, it's done. Tell me the line number at which you are not able to understand, and I would help you with it. So let me just make it full screen. Now tell me the line number at which you are not able to understand. Okay, I should position it the way it was so that you would have a better viewing angle. Okay, I would just make this. This is done. Now tell me. This is the stack declaration and this is the return statement. I would wait for the next 1 minute and then I would turn off. We can simply empty stack vectors. We need no need to use. We can use empty method for vectors as well. Empty method for vectors exist? I don't know. Might be the case that exists. Okay. Could you please explain line number 19 and 23? What is line number 19 and 23? Let me see. Line number 19. If okay. I would explain. See, if the last element, okay, if the last element size is same as the current element, then they both would just splash. That is why we have removed the last element, but we have not inserted the current element. Okay. Line number 23 is all about that if everything is gone, then now insert the current element. If there is nothing after the removal and all. Okay. Or or the last one is the right element. So if there is a right side going element, then there are two scenarios. Suppose I am moving on the right hand side. So one more is moving with me. What issues I would have? Okay. Same manner. Okay. What about chat GPT? As of now, chat GPT is not able to solve DSA problems which are not very famous or something. Okay. Like problems which require innovation, it is not able to solve it. Okay. So I don't see any fear regarding that. Earlier also famous like standard questions were googleable. Now also standard questions are out there on chat gpt. Okay, empty method exists for vectors. Fair enough, I didn't knew. Used to have vector dot size. Basically I never explored it. All right, so any more concern or issues, I would be waiting for the last 30 seconds. So if you're watching this stream in the recorded version, feel free to like the video or comment on the video so that the reach of this video could be increased. So I would wait for the last 30 seconds and then I would turn off the session. Let me just see if any more. Okay. Most welcome, Rishit. Crystal clear. Thank you. Chalo. Good night, everyone. Nothing, bro. Thanks for your response. No problem. चैट जीपीटी ने अरे भैया गूगल कर लो मिल जाएगा चलो